In this video, we solve the numerical of friction head loss in a pipe. So first we understand the problem statements. Find the head loss due to friction in a pipe of diameter 300 mm, means D is given, and a length of 50 meter, so L is given, and through this pipe the water is flowing at a velocity of 3 meter per second, so V is given, and we need to find out the head loss by using the two formula. First one is by using the Darcy formula, and second we need to find out by using the Chassis formula. And for this Chassis formula, the Chassis constant C is equal to 60. So first we write down the given data. Apart from that, take the kinematic viscosity V for water is equal to 0.01 stock. So first we write down the given data. So first data is given, diameter D is equal to 300 mm. Second, length of pipe L is equal to 50 meter. Third, velocity is given, V is equal to 3 meter per second. Chassis constant C is equal to 60. Kinematic viscosity 0.01 stock, and stock is also called as the centimeter square per seconds, and we need to convert them in meter square per seconds. So we know that this 100 centimeter is equal to 1 meters, okay, and the meter is the larger units. So we need to divide this 0.01 by using this 100 into 100. Why? Because 100 centimeter is equal to 1 meter, and here the unit is centimeter square. So we need to divide by 100, again divided by 100. So in short, it is also written as 0.01 into 10 raised to minus 4 meter square per seconds. Also we need to convert this diameter in a meter, so it is 300 mm. So 300 mm divided by 1000, so it is equal to 0.3 meters. So here we convert all the unit in a same, means all the parameters in a same units, that is in the meters, and we need to find out the HF. So first we find out the HF by using the Darcy formulas. So this is the Darcy formula, that is HF is equal to 4 FLV square divided by D into 2G. So in a last video we already derived these equations. Okay, so if you don't know how this equation is derived, then I request to watch the last videos about the Darcy formulas. So as in given data, we can see that the F is not given here in a given data. L is given, V is given, D is also given, and the G is the gravitational acceleration, so it is 9.81. So here F is not given, so first we need to find out the F. So find out the F means what is the F? So F is the coefficient of frictions, and coefficient of frictions is find out from these equations of the Reynolds numbers. So first we need to find out the Reynolds number. The Reynolds number is denoted by Re. So Reynolds number is equal to velocity into diameter divided by kinematic viscosity. So here the velocity is given, that is V is equal to 3 meter per seconds. Diameter is the 0.3, so 300 mm is given, so we already convert that the 300 mm is equal to 0.3 meters. We also put the kinematic viscosity, it is 0.01 into 10 raised to minus 4. Okay, so we calculate this equations, so we get the answer. Reynolds number is equal to 9 into 10 raised to 5. Now from that we have the equation of the F, means depending on the value of Reynolds numbers, the equation of the F is different. Okay, so here the Reynolds number value is more than 4000, so here we take this equation, F is equal to 0.079 divided by Reynolds raised to 1 by 4th powers. Okay, so here we put this value of Reynolds numbers. So Reynolds number is 9 into 10 raised to 5. Okay, and we solve these parameters in a calculator. Then we get the answers of the friction coefficient F is equal to 0.00256. Now we have all these parameters. So we putting this value of F, L, V, D and G in this equation of the HF. So here we putting this value of all these parameters. So 4 is as it is. F is equal to 0.00256. L is equal to 50. V is equal to 3 divided by D. So diameter is the 0.3 meters into 2 into G. G is equal to 9.81. So we solve this equation in a calculator. Then we get the answer of the HF in a meters. So answer of head loss due to friction HF is equal to 0.7828 meters. Now seconds we solve by using the chassis formula. So chassis formula is the V is equal to C under root of Mi. Okay, so V is the velocity. So velocity is given. Chassis constant C is given. So what is M and I? So first we need to find out the M and I. So M is equal to D by 4. Okay. D means diameter. Diameter is the 0.3. So 0.3 divided by 4 we get the answer. It is the 0.075 meters. What is the I? I is equal to HF divided by L. Okay. So first we find out the I, then after we putting this value, or you can directly put the I is equal to HF divided by L and directly calculate it. But here first we find out the I. So we putting this value of V, C and the M in this equation and find out the I. So V is equal to 3. Here we putting this 3. Capital C means chassis constant is given 60 under root of M. M is equal to 0.075 into I. So we can find out this I from these equations. Okay. So I is equal to 3 divided by 60. So this 60 is go on to the right side. So it is go in the divide portion. So 3 divided by 60. Okay. And first we do the square on the both the sides. Okay. Then here we do the square and this under root is removed. Means this square of this tab is done. Then what the happens? The under root is removed. So this 0.075 is supplied also on the left side. So it is the 1 divided by 0.075. So we'll solve this equation in a calculator. We get this answer 0.0333. Okay. So this is the value of I. So this indicate the I. Now what is the equation of the I? So equation of the I is equal to head loss due to friction HF divided by L. Now we have the value of I, we have the value of L. So we are able to find out the HF. Okay. So HF is equal to I into L. So here we putting that the HF is equal to 50 and here we putting this value of I. It is 0.033. Okay, so this 50 is multiplied with this 0.033. Then we are able to get this value of HF. So value of HF is 1.665 meters. Okay, so here we complete our numericals to find out this HF by using this two formula, that is from the Darcy formulas and the chassis formula. So thank you for watching this video. If you learned something, then like the video and subscribe my channels for watching the more video related to FMHM as well as the other subject of mechanical engineering. And don't forget to share with your friends.